Okay, today we're going to be talking about arrays. So essentially, they're a convenient way for you to store multiple of the same data type. So take this, um, and it makes it really easy and convenient instead of having to keep track of multiple of the same singular like int variable. Like you need like 100 of them for to keep track of bank balances of 100 different people, right? So instead of storing them as separate integer variables, like person one, person two, person three, so on, you can store them all in an integer labeled, say, bank, and then have each person represent a different spot in that bank array. It just makes it very fluid for and streamline your code instead of having to initialize multiple variables. It just saves you a lot of typing, is what you could think. Um, so in order to initialize an array, or to declare an array first, um, you can see it is similar to the original integer in that it has the data type followed by its the variable name. However, it differs in that it has this bracket in front at the end immediately following the variable name. And that's important because it tells the compiler how big you want the array to be. And in the case of just in this lobster compiler, it's very important that that you have that initialized or have that written in the code, or else like you see here, lobster won't accept it as a proper way to initialize an array. So listed down here are three different and perfectly valid ways to initialize an array. So the first one is um here where you could uh um you list the size, and then afterwards you have these brackets, and inside the brackets you put a certain number of variables up to but not past the size of your array. So say let's take a look at bank two. It has 0, 2, 3. So what the compiler will do is it'll see this bank bank two, and inside of bank two, it'll store 0 at position. Oh, this is another thing about arrays. They have this silly quirk where they uh where in order to access it, so let's say bank two 0, right? It would be the same as the first position in the bank two array. So um so it's as you can see, the way the user interacts with, or how we interact with the code, is different from how the compiler visualizes the code. So 0 will be put in position 1, uh 2 in position 2, and 3 in position 3. And in order to access them, uh this would map to 0, right? Um and then 1 would be like bank 2 at location 1 would be 2, and bank 2 would go to 3. Okay. And then other ways to initialize an array. So you have this one, bank 3, where you don't need the a constant in front of the, or in between, inside of the bracket, but and what a compiler would do is it would automatically detect the number of data types of data types in these big in the dotted, what are these called, dotted brackets. I'll look up the name later, but and it'll automatically detect how how many are in there, and it'll allocate the size properly. But lobster doesn't do that. So but when you're writing your code, keep that in mind. You can use this method. And another important thing to note about arrays is that after you initialize an array, you cannot add more memory to it. Otherwise, it'll cause errors and other things like you go out of scope. And we can talk about that more later. And then the last way to initialize an array is the same as bank 2, but instead you allocate more memory than is necessary in your than stated in your bracket operators in your brackets. And so what it will do is bank 4, it'll put at position 1 for us access is 0, and then position 2 or position 1 will be 3, position 2 will be 4, and then 3, 4, and 5 will all be set as zeros. So this is essentially the same as zero, 0, 0. So essentially that's what the compiler would view bank 4 as, and they're basically equivalent. And now let's try going through a practice problem. So let's take a look at the problem statement up here. Let's declare an array R that holds 5, 100, 3, 0, 90, 13, and 105. So using the methods of initialization we described above, we can do it in 2 ways. We could do it like this. We can count out the number, the size that we need, like 1, 2, 3, 4, 5, 6, 7. 7. And then we'll just hard code the array and give it all the values it needs by copying and pasting from up there. And then end it with a closing bracket, and our array is initialized. Now, in order to access all the elements in the array, it goes back to a concept we learned previously. So, for loops, and as we can see, continuing this problem down here, we need to write a for loop that counts the number of numbers in array that are greater than 20. So, in order to access the for loop, int 0, we have to remember that we need to initialize the integer I, and then make sure that it's less than array.size I plus plus. There's no dot size. My bad. I need to brush up on the arrays. So we can just hard code that, where since we need to remember that the access using the bracket operator, this, for an array, it starts at 0 is the equivalent of position 1. And so on and so forth. So the actual size of the array, 7, and then the last accessible location would be at 6, right? Because 0 to 1, and then inverse 7 to 6. That was a little quick. Some people might not get that. We can go over it again if they have questions. And that's exactly what our for loop does. It'll start at 0, and it'll go all the way up to 6. But then once it hits 7, as you can see by the less than 7 in our for loop, it'll stop before it has a chance to access, before it can even attempt to access the array at bracket 7. And now, in order to count the number of numbers in array that are greater than 20, how could we do this? The first thing I would think of is an if statement where we can just check, if this number at location array like blank is greater than 20, then we can how do we count it? Oh, greater count. We can increment it, right? So like every time we see a number that's greater than 20, we can add 1 to greater count, and that's how we count the numbers. So we could do if, and then how do we access the array again? Array at position. So like we will want position 0 through 6. So I kind of rushed the step a little, but I would explain this before I would explain this here and then proceed into the for loop. So now we can and instead of having to type out 0 through 6, we can just use handy dandy variable I. And if array I is greater than 20, right? Greater than 20 here, then we can increment greater count. And then that should be our code. Let's see if it works. Similar. So you can see what the compiler does. Let's see, step through it. You can see on compile time, oh, it initializes array 7. And it'll it'll go through all of the elements inside the brackets and set them into their positions in the array. So step, 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 and it sets them all equal. And before that, they're just random numbers, or uninitialized, so you won't know what numbers are there. And that's just not really good for a program because it has unintended consequences. And now and then we initialize greater count, and then we'll loop through the array. Every time it sees a number greater than 20, it'll increment. So right now we're checking location 3, and that is 0. And if array 3 is greater than 20, is 0 greater than 20? No. Then it'll evaluate the false, and it'll skip the if statement. And then loop back to the for, add I. I is now 4. And let's check if I4, which is 90, down here, is greater than 20. Yes, it is. Then we'll increment greater count by 1. And if we just run the entire code, it'll print out 3 elements are greater than 20. And if we can verify this by checking here, how many, and we can count for ourselves, how many numbers are greater than 20? 1, 100, 90, and 105. And that equals 3. And that's my rundown of an array and a practice problem. And this is my application for being an EECS 183 IA. I hope you enjoyed. Thank you very much.